So my topic today is DCIM from an operator's perspective. Now, I've been an operator for probably 30 years, and during that time, I've designed, I've built, I've commissioned, and I've transferred to operations probably $4 billion worth of mission-critical infrastructure. But the key is every bit of that, every one of those projects, every bit of that work ultimately became mine to operate. So if I've made a mistake in the design process, if I made a mistake in the execution process, it all fell to me. Now, also during that time, I've probably installed millions, if not tens of millions of dollars worth of monitoring software, building control systems, monitoring systems in general. And the one key thing that I can take away over the years is that those systems, while very necessary in the environment, don't provide the information I, as a data center operator, need to have a full end-to-end grasp of what's happening in my environment. So that's DCIM, hopefully to fill the gap. So I'm going to talk a little about who Digital Realty is and what my role is there. I'm going to put some definitions out of what the industry is saying, what DCIM is, and align that with what my thoughts are. Then I'm going to talk about defining operational requirements for a DCIM platform. Now, not doing that, because that's really the first step. If you don't do that, it's like going to the supermarket without a shopping list. You really need to understand what your business requirements are, or you're never going to get them satisfied with any product that you actually might ultimately deploy at your facilities. Then I'm going to talk about the data challenge. DCIM, from my perspective, is a data challenge. It's a huge amount of data that you need to manage and aggregate so that you can actually make meaningful decisions based on that data. I'll talk a little about who the players are from a market vertical perspective in the DCIM market. And then I'm going to tell you what a DCIM platform from my view should look like. And you may have seen the press release and the digital booth. We just launched yesterday our Envision DCIM platform. So I'm going to talk a little about how that's structured, how that matches our requirements, and how that was driven based on requirements. And then I'll try to sum up with the value proposition, and so let's take it from here. So Digital Realty, 23 million square feet of mission-critical space, data center space, 120 plus properties in over 30 markets across 4 continents. And by the way, these numbers are already getting stale. We are growing so fast that these numbers just keep ticking up. And so since the last time I looked, I think the numbers are actually greater than this. But 550 plus customers in pretty much every market vertical you can think of, from financial to pharmaceutical to internet service providers to social media, you name it, we have customers in that space operating out of our data centers. 700 data center professionals, $1.3 billion of revenue last year, a $14 billion enterprise value, and our performance over time has earned us an investment-grade credit rating. Now, if you've heard this, the description of this slide by our CTO, Jim Smith, he likes to talk about why big is important, and he'll speak about supply chain and procurement and the ability to execute construction. And from my perspective, I'm much less eloquent. I'm just going to say that's a lot of stuff, and my job is to operate it. So I'm Senior Vice President of Operations at Digital Realty, and my job is to make sure every one of those sites operates consistently, that it's reliable, that we're driving performance, and that we're delivering a service to our customers that is best practice. I have in my group alone, if you include both my direct data center professional and managers and the data center operational support staff, over 1,000 people in our operation. We have 156 TKFs. TKFs is Digital's turnkey flex data center product. And we also have 178 what I'll call custom pods. Now, the TKF product, if you don't know, is roughly a block of IT capacity. It's about 1.1, 1.2 megawatts with dedicated infrastructure, UPS, generator, cooling, everything dedicated. So it's a discrete data center space. The 178 custom pods are really part of either our build-to-suit, where we build specialty data centers for, or I should say we design specific to customer requirements or properties that we've acquired. But the key here is we have a very large deployment of very consistent and evolving product that we've designed. We also have a massive deployment of almost any kind of data center topology that you can think of. And when you think about that from a data perspective, that's an enormously large data set. If you can get your arms around it, the amount of data that you can mine out of that data set is pretty amazing. And so that's what DCIM is. We've been reporting for 6 consecutive years of 5 nines availability of all of our data centers. That represents 554 million operational minutes, or 1,000 plus site years of operational performance. So there's scale here. Now I'm going to put a disclaimer up here. When people talk about DCIM, they want to see fancy screenshots. They want to see rotating cabinets and 3-dimensional things flying around on the screen. But that's not what DCIM is to me. You know, I have a very close friend who is actually a CEO of a software company. And several years back, we were walking through this very massive data center that supports the financial services industry. And as we came to the command center, there were a bunch of screens up, and he comes from the BMS world, so he was looking at one of the screens and was remarking about what a great implementation. And I remember looking at it, and it was a chiller plant kind of schematic on the BMS, and you know, you had your cooling towers, and you had all this animated water flowing off the towers, and you had this animated water flowing through the pipes. And he says, that's really cool, and it is cool. And vendors know you like to see that cool stuff. But at the end of the day, I said to him, if we were looking at this screen 10 years ago without all of that animation, we'd still have the same information. So DCIM, to me, is not about fancy screenshots or fancy animations. It's about measuring performance at every level of an operation. It's about transitioning an operation to a data-driven performance model. It's about delivering value and consistency across all of our operational silos, and most importantly, it's about delivering commercial performance, running a data center as a business and not just as a need to have, but a must have, and driving commercial performance in every decision that you make. So this is from the 451 Group's definition of DCIM. You've probably seen it before if you've seen DCIM presentations. But the key here is it starts on the bottom with kind of sources of data. It works its way up through the stack to integration of data, and then ultimately talks about ways some of that data is aggregated to derive performance within the environment. The two call-outs here, which I, by the way, agree with, are on the far left, the MEP infrastructure, which is control-related, controlling of MEP infrastructure. And on the right is the IT systems, provisioning and the various network control functions. Those are held out on this stack from being DCIM functions, and I would agree with that. I'm very strongly opposed putting DCIM, I should say control functionality into a DCIM platform, and I'll talk a little about why I believe that. Okay, so when we looked at our Envision product and what we wanted to deliver, the first thing I did selfishly as an operator say, well, what do I need? And so this is not the whole list, but these are kind of some of the key elements of what I felt we needed to accomplish to deploy a successful DCIM product or platform. And obviously a global view. You saw 30 markets, 4 continents. I need to be able to get to access to every single one of my data centers. I need to be able to look at each of them. I need to be able to compare data center to data center across region. I need to be able to compare system to system across region. So I need a global consolidated view of all of the information surrounding my data center. I need secure tiered browser-based access. Now, that's a lot different than saying that you're web-enabled or internet-compatible. Browser-based is just that. All you need is a desktop or a laptop with a browser on it. You don't need any thin clients. You don't need any thick clients. You don't need any applications installed on the platform. You can look at it through a browser. And that's really critical for an operation like mine where, as I mentioned, I have over 1,000 people just on the operations side. I don't want to have to install software on all of their computers. And then our customers don't want and probably won't accept in many instances for us to be able to push Java onto their desktops in their organizations. Those represent both security risks for them. It also represents an operational risk from their help desk perspective, because if we're starting to modify desktops within their environment, that causes them headaches. So the key here is we wanted a very simple browser-based interface so that you can access everything within the platform and not have to install anything extra on the servers. Intuitive interface. Now that sounds intuitive, but again, if you hear from the scale of my operation and the number of people who are going to access this, I don't want to spend the rest of my career training people on how to use the system. I don't want to have to go back and forth to customers and say, no, you don't do it this way, you do it that way. So we need to have a very clean, easy navigation platform that is intuitive to people and they can get to the information they need quickly and easily with minimal training. I'm going to talk about data scalability a little bit more later, but you can imagine with that scale of data, the amount of information I have to process is pretty massive, and you better have a database that can handle that kind of data scalability. Powerful and flexible data mining, right? So, and I'll talk about this again as I talk about the structure of Envision, but the primary goal for me is to get data into the system and into the databases. We have a good sense of what we need from a dashboard and reporting perspective today, but I can assure you that 6 months from now, a year from now, 5 years from now, we're going to come up with other ideas. And we want to be able to mine that data and know that the data is in that database so that we can mine it in the future and know that it's there and not say, oh my goodness, now that I have this new requirement for reporting, now I have to start collecting that data and I got to modify all the systems and then hope to start building some history with those systems before I can mine it. So that's really critical. Bidirectional access to data. Now, DCIM is mostly about pulling data from other systems into a centralized location so that you can actually provide that function. But in some instances, we're going to push data. We're going to push data into procurement systems. We're going to push data into financial systems for invoicing. So to have that bidirectional capability and open database is really critical. Real-time condition assessment. So whether the site is in Singapore or Sydney or Hong Kong or in Santa Clara here, I need to be able to see real-time condition assessment for all of the key parameters of my sites. And I need to see that locally at the site, but I also need to see that in my command center. Asset tracking and capacity management. So several weeks ago, Digital announced its connectivity initiative. So it's a broad-based project to connect up our data centers, which will require quite a bit of IT infrastructure to manage. That needs to be managed by our DCIM platform. Further, we have a pretty large retail colo operation, which includes full rack and stack and cabling and cross-connect management. So the system has to handle that as well. And then I say here cost allocation and financial analysis. Most systems that you see that are reporting on infrastructure talk in terms of how much energy you used, how much energy you saved, those types of parameters. But very rarely do you see them align those numbers with actual dollars. And if we're running a commercial business, I need to be able to not just see how much energy I am consuming or saving, but how much that translates to in dollars, because that's going to be different in different utility regions and rate schedules. So I need to know dollars. I need to be able to think in terms of dollars if I'm going to run a commercial operation. And then, excuse me, rapid cost-efficient deployment. I have 120 plus sites. I can't get to each site and start a big custom project to start figuring out how to gather all of this information. It needs to be able to be deployed quickly, rapidly, simply with minimal resource at the facilities, so that we could pull that information back to our central location and get that done quickly. Now, we kind of went through this needs requirement, but we then also talked to our customers and said, what do you guys need? And turns out what our customers are asking for aligned very nicely with what I needed and what our operation needed. So it was good validation that we were on the right track. So now I'm going to talk about the data challenge, because It's all about the data when you're talking about DCIM, because that's what most people feel they're lacking from the systems they currently have. So I talk about it in kind of two silos: data sourcing, which is where you collect information, and then the characteristics of the data that you're collecting. So from a sourcing perspective, you'll see where, and by the way, you notice I hold DCIM away from those other systems. There are some who think that one of those other systems might be a good starting point to build a DCIM platform from, but in my view, it's not intuitive that those systems, whether it's on the MEP side, which means that they're they're located locally. Why would I pick one location and take a system there and try and build an empire for all of the other systems out of that one location? So that doesn't make sense to me. And then the other systems, which the way the databases are structured and or the security of the system, certainly financial systems, doesn't make sense to me again. So it's not intuitive that those systems become the basis of a DCIM platform. So I hold that away. So I'm going to talk a little about database structure and the difference between these types of systems. And I think the primary difference, and it's one that you need to know when you're talking about large-scale operation and pulling large amounts of data, is the difference between a database that's structured as a high volume and high transaction database or a high volume and low transaction database. So let me talk about that a little bit here. And it looks like the font's a little messed up here, but hopefully you can read through it. So I'm using an example here. So let's look at the IT asset management world. And let's take an assumption that you have a customer who has 20,000 servers. And so as soon as you have 20,000 servers, you have to enter 20,000 records into a database. So it sounds like a lot. It's not a terribly big number for a database. You can actually do that in a spreadsheet, and many people do. But let's call that volume, 20,000 servers. And let's say that operation refreshes their servers 20% annually. So every 5 years, they completely change out all of their servers. So 20% of the servers are going to change every year. So those are, again, hits to the database in terms of transactions. And then, you use these systems to also manage your cable plant. So just for the sake of trying to come up with an example, I just said, well, for every server, we're going to manage 2 cable transactions per year. So when you add up the numbers, you end up with 44,000 transactions to the database for this profile. Now, I could be off by a factor of 10. I could be off by a factor of 100. As you'll see in a second, it won't matter because the difference is going to be really big. Now let's look at the MEP side. Same 20,000 servers, and let's just say we put they're dual corded, and we put them in 500 racks. So 40 or so servers per rack, and you have 500 racks, and they're dual corded, and let's just say the customer wants to measure not just every circuit, but every plug. Now, that most people will say, I don't need that, but we do have customers who will want that, and so we have to structure the database to handle that kind of volume. Well, these types of points are power cooling, which means they change. So let's just say we're going to take a snapshot every minute. There's 525,600 minutes in a year. So if you do the math on that example, you have 26 billion transactions into the database on an annual basis. But that's not actually accurate. That's just information coming in. And the information coming in is usually amps and volts. You still have to do the calculations on that, and you still have to assign that to servers and racks. So it's actually multiples of this, and this is for 20,000 servers or 500 racks. We have many more than that. So that's the difference between high volume and high transaction. And if you haven't coded your database to handle that kind of volume, you can't do that day 2. You have to develop a database that can handle that right from day 1. So who are the players in the marketplace? These are the kind of the verticals, at least as I see them. There's 4 of them. There's the building controls industry. There's the ITC Platforms industry. There's some start-off offerings, and then there's some hybrid offerings. So let's take those kind of one at a time. So the building controls industry, right? These are mature technologies that have been around for a long time. They're traditionally hardware-based. So you know the adage, if you're carrying a hammer, everything looks like a nail. Well, if you're in the building controls industry, every problem needs some kind of a proprietary device to fix it. They sell hardware, and so So, building control people always need more hardware to do whatever, to solve whatever problem you want. Most of those devices are proprietary, and they use proprietary protocols. They have proprietary data structures. And then they're customized solutions. So if you've ever installed a BMS system at a facility, a data center, you'll find that that whole project was a custom project. All the devices arrived, they were all wired up, but then you spent a lot of time mapping points and mapping information, and usually you're kind of running up to the end of the job while they get all that commissioned so that they can be ready for the commissioning. So a very custom project, and after you finish that project and you'll build another data center, they start all over again, and it's another custom project. And there's a reason for that. Building control systems are not designed for data centers, they're designed for essentially anything. So that same system that's designed for your data center is actually designed to do a shopping mall or a high-rise building or an industrial plant. So there's only so much pre-built stuff that they can put in there and still make it relevant, so it drives a lot of custom work in the field. They're complex to install, as I mentioned, and complex to commission. You need them, by the way. DCIM does not displace this, but it just doesn't feel to me that this is where you want, you don't want a custom platform that every time you want to make a change, because lots of changes happen in the data center environment, you don't want that to be a custom process every time you make that change. They're also complex to operate. So you have to train people. You can't just walk up to a BMS workstation and start operating it. You need to know how it's configured. You need to have some level of knowledge of the infrastructure that it's monitoring and controlling. And there's also risk of misoperation. So again, it's not intuitive to me that this platform or this type of technology is where DCIM belongs. Although it is a contributor and it is certainly a data source and you need it. I'll kind of finish up in these bullet points. Limited data scalability. Now you may ask, well, it's an MEP system. It therefore, isn't it able to do that very rapid, high volume communication and data transfer? And it's yes and no. Actually, what happens in a BMS system is you have lots of controllers, and controllers are speaking to the actual controlled devices, and there's very rapid communication between the controllers and the controlled devices. But in terms of the head end, very little information actually passes back to the head end. So those databases are usually fairly light and not able to handle the volume that we're talking about. So that's the difference, at least from what my experience. And then they're expensive, very expensive to install. So anyway, that's the building control player. Now the ITC Platforms is a very broad topic, so I'm going to probably mostly focus on the asset management type systems, because there's all kinds of network control systems and provisioning systems and those types that are not even looking to be in the data center in DCIM world. So I'm not going to speak to that. But in terms of asset management, these are software centric, so they're not hardware based. Typically, they're more software centric. They have typically workflows built in, everything from the procurement all the way through the deployment of IT equipment. And those can be very good, but if your operation runs in a particular way, if you're going to deploy these kinds of platforms, you better be willing to change the way you do your processes to align well with the software, or you're not going to get compliance. But if you're willing to do that, or if you're looking for a platform to give you that guidance, these can do that sometimes pretty effectively. A lot of times they are thick client topologies, though. You have to install stuff on the workstation that you're accessing the equipment with, because that's how they get the 3D effects and all the spinning racks and all of that type of stuff. So a little bit of a limitation from my view in that area. And anyway, they're also expensive to install as well, and you want to make sure, because they require a lot of data input. You'll find when you talk to people who've deployed them, they've had to dedicate several people in the operation, and it's usually not vendors, it's usually the people within the operation to actually populate all of this information. Then you have the startups. Now this is kind of a mixed bag, because in many instances they're just people or companies that have kind of targeted a specific problem or attribute within the data center environment. For example, they may have control crack units. So they're a platform that's figured out how to tune the air handling within your data center to deliver more energy efficient cooling. And those are typically, as I said, very siloed, and they are, as I mentioned before, I'm not one for control systems being part of DCIM, but they have their place. These systems have their place, and they often have paybacks, and they're worthy of looking into. But the fact that they just put on their opening screen a speedometer that says PUE doesn't make them DCIM platforms. Then you have the more complex, or some more complex, the CFD visualizations and server power capping type control programs. So there's a variety in that marketplace, but there are also some startup players who actually have gotten it right and kind of match a lot of the requirements that I'm talking about. So they do exist, but you have to search them out because there's very few. The hybrid offerings are essentially a mix. The way I look at it, whether it's the parent company of the building controls industry or the parent company of an ITC services company, what you're finding that what they're doing is they're buying up other smaller companies and trying to put together an offering or a suite of applications and call that DCIM. And some of them look okay, but each one of those had their own individual problems with data, and now as you see, as they try to integrate these packages, you'll find that the delivery or the time they say they can deliver these platforms is way past what their original projection of when they could deliver them. So they're, in some instances, years late from when they said they would have it, and that's, I believe, purely a function of it was harder than they thought to integrate all of these databases. Okay, so in my view, this is what a DCIM platform should look like. This is the functional map of our Envision platform. And there's 3 discrete silos of functionality here. There's the data sourcing and collection, there's the data structure and analysis, and then there's the visual display and data reporting. You'll find most DCIM platforms focus on that visual data display and data reporting because you can do some cool stuff there and it attracts people. It attracts people. People will walk up to the monitors to see that, but they don't necessarily always focus as much on the data challenge. And so let's talk a little about each of these segments. So the data sourcing and collection. Global reach across all regions and locations with an open data model. I don't want proprietary software. I don't want proprietary hardware. I want to use off-the-shelf open components, and I want to grab as quickly as possible from each site the information I need and pull it into a non-proprietary format. I want to make sure that the packet sizes and the data compression that transfers it to our head end are efficient and not straining network resources. I want to be able to transfer data back and forth. So I may, in some instances, as I said, I'm pulling data. In some instances, I'm pushing data back to other applications. I want to be protocol and device agnostic. I want to easily communicate with everything that's out there, and I want to do it with minimal hardware and no proprietary hardware. I mentioned the bidirectional exchange capabilities, and then kind of wireless sensors. It's not a requirement for DCIM, but the point there is, in many instances, there's information you want to get, and it's not easily gotten or inexpensively gotten through a wired network or existing systems, and you want to be able to quickly and be able to deploy some wireless topologies to fill the gaps in the data collection effort and not have to spend a lot of time or money in the field rewiring and reprovisioning at the site level. So I'm going to spend a minute on this data structure and analysis. So, and I broke that, as you see, into 2, and I'll talk about the top part, the data storage and analysis. So this is a centralized, high-volume, high-transaction enterprise structure. It's sitting on high-availability architecture because it's the central point, and it's carrying all the information. So we want a lot of resiliency at that central location. I need less resiliency at the site level. It has defined algorithms for data translation. So as I mentioned before, when you're in the controls world, a lot of how the data interacts is driven by custom coding. In the data center world, when you only have a data center problem and all of your challenges are data center specific, a lot of those problems are predefined. You know where the power from a branch circuit is supposed to go. You know how that's supposed to be treated. You know how the cooling system is supposed to be treated and how the racks and all of your IT assets are supposed to be treated. So if you know that, you can predefine hierarchies of data, and you can build the data sets so that they can accept that data very rapidly and not have a lot of customization. And you only do it in one location at the central head end. And then you can just pull information from all around the portfolio into that. And in there you have the data validation, the aggregation and compression of that data. So some data you want to keep, well, Envision keeps all of the data permanently, but some elements of data, as it starts aging, become less and less critical. And so you may switch from once a minute of data collection or data storage a year out, and you might say, well, you know what, I don't want it once a minute, I just want it once an hour, and I just want to know what the high, the average, and the low was for that hour a year ago. So that's where you build this functionality, and you build it custom to the type of data. So if it knows it's power information and we want to have more granular information on power, we will build that data storage into that hierarchy. But if we need less granular information over time with the mechanical, then we can do that. So that's all pre-built and therefore rapidly and allows for rapid, I should say, onboarding of new facilities. And then the network monitoring control. We want to make sure that we're not losing data, we're not dropping data, and what are the protocols if it loses, if it drops a cycle or two, what does the database do? Well, that's all predefined in the program so it knows what to do. And then I'll spend a minute on this hierarchy. This is really some of the magic of driving a product that can deliver very consistently, very rapidly. So what do I mean by a hierarchy? Well, as I mentioned before, in some of the other industries, everything is custom built. Everything is operator dependent. You go to the operator and say, how do you want to display this? How do you want to display that? But if you can find a hierarchy or a structure of data that always applies to your data center, and then you can pre-build it, and you can improve performance, you can improve reliability, and minimize the amount of mistakes that people can make in the programming. So let me give you an example of that. And there are several, but let me use this one. And I developed this and started using it probably 13 years ago. But if you look at the bottom of that hierarchy, in the example I'm using here, it starts off with software services, your email services, your database services, whatever the services of your business are. Those services are always supported by some type of an IT device, always. And those IT devices are always installed in some type of an IT footprint, a cabinet, a rack, or some dedicated footprint. And those footprints are always installed in a room. And the room is always installed on a floor. And a floor is always part of a building is always part of a state is part of a region is part of the globe. No matter what kind of data center technology you have, it'll fit into that hierarchy. And if you can not break that hierarchy and fit anything in there, you can pre-build that. And all of a sudden you have a platform that you can refine and make sure that data is always represented correctly. Now, if you have that hierarchy, and again, there are several of them, but this is a core one, you can now think of this. You can now write a report. So let's just say I wanted a report on my IT assets, and I want to know what services are running on them. I want to know what the power draw is, whatever I want in that report. I build that report one time at the central location, and then you can point that report to any layer of the stack. So if I point it to a rack, I instantly get a report of all the IT assets in that rack and all that information. Or if I point the same report to a floor, it then gives me a report for all of the IT assets on that floor, all the way up through the globe. So all of a sudden, you can very efficiently drive powerful reports. You're not having to put reports together all over the place in all different locations and retesting them and rechecking to make sure that they are actually reading correctly. You define them once, and they're available to the entire portfolio. So as I said, there are many hierarchies, but that kind of gives you an example of the power of the database structure behind there. And then the last bit here is the the stuff that you see. A web services product, a true browser-based web services product. You size the hardware on the amount of concurrent users, just like any other web service, and you're able to deliver that to your customers. I'm running out of time here, so I'm kind of speeding it up a little bit. So the value proposition. Transition from an ad hoc reactive management to a sustainable performance-driven model or environment. And leveraging system scale, I mentioned that big portfolio of properties. If I can leverage the information from that and what I can learn from the operation of all of those systems, thousands of UPS modules, thousands of crack or CROI units, all of those devices operating, if I can monitor them and I can do some aggregating and reporting on it, I can really determine where my performance gaps are. And then enable relative versus absolute analysis across sites. So what do I mean by that? If you had, let's just call it a CROI unit, and it was a constant volume, let's just say, and you said, well, we're going to install a variable frequency drive on that CROI unit. So when you do that, you're going to save some energy. And so that amount of energy that you save is an absolute value. So you can measure it. That's your absolute value. But what if you have thousands of these, tens of thousands of these? Well, if you can align the energy savings or the energy consumption of all of those units relative to the UPS load in those facilities, you're going to come up with some numbers that will tell you, here's what I should be seeing across the portfolio, and you can identify the ones that are actually performing better or worse and drive your operation to figure out why they're not operating within that profile. So the absolute tells you that you're saving something, you've measured it, but it doesn't necessarily tell you how much you should be saving. And when you're running a large operation, I'm looking for variances out of the mark. It's a SaaS, I'm just going to skip a couple here, but it's really a SaaS-like environment, which means centralized change management, centralized maintenance, and upgrade. So no work at the sites, all the work is at the head end, and every change you make instantly is available to all of the users. And then no on-site programming and custom appliances, no configuration at the sites, very minimal work at the sites, and you're pulling all that data in. So in summary, the past, stranded data, lots of expensive systems, but you're not really always able to get all the information you need, proprietary software, lockdown hardware, and lots of vendor dependencies. In the future, which is Envision, unrestricted access to data, seamless data exchange, vendor and platform independence, and what we're really talking about is a big data model. If you think of the four V's of big data, volume, velocity, variety, and veracity, it's kind of what I just said. It's what we build into the database and the application that we're delivering. So with that, thanks for listening, and I'll take some questions. Anyone with a question?
Yeah, I got a question here. When you get to each one of your sites, and I'm very familiar with the...
okay.
I'm very familiar with digital. You have all kinds of different BMSs and UPSs and all those things out there. Are you putting like a little black box at each site that all that stuff goes to, and then it shoots back to your big old head end? Because you do have a wide variety of stuff out there that is all proprietary and all that other good stuff.
No, great question. So, no, there's no black box. There is, so what happens at the site is a off-the-shelf server sized for the data volume that's expected at the site. And on that server are polling engines that can speak those protocols and then just connect up with the various systems and pull the data through. So it's not a black box, it's off-the-shelf stuff, other than the software, which has, some unique capabilities to kind of connect up over all of those protocols and pull the data. Yes?
Do you see any future integration of building information modeling with DCIM?
Yeah, so actually, I guess BIM would be I guess I'd call it in that startup group that I mentioned, because it's somewhat new. It's not that new, but it's somewhat new technology. And the challenge I would have with that, I would say BIM might be in a place where we push some information. The challenge being typically the BIM software I'm seeing is what was the term I was using? You need to install software on the desktops. So they're very visually oriented and can often require lots of either processing capability or thin clients or even thick clients to be installed on desktops. So how do I push BIM out to thousands of users? So I think some things need to happen in that world, but certainly, and not everyone needs a BIM, not every user needs a BIM type system. So I would say for those who do, we can certainly push information into a BIM model and populate data into that. But in terms of being the core or in that circle of DCIM, at least now I wouldn't think that a BIM model would be the way I would go. Some questions back here?
Hello, David. Bruce Myatt. One of your goals is to have vendor and platform independence. To me, that means PLCs. What is your opinion about PLC versus DDC? And second of all, what's your opinion about automation of the facility? And that is to control your HVAC with other data, with data from the plant.
Sure. So I want to be clear. DCIM is not a control function. So there needs to be control hardware at the site that's not part of the DCIM platform. So we will have BMS systems and the various SCADA systems that you would deploy, to the UPS SCADAs, the generator SCADAs, the BMS systems, those systems, and those are in direct control of the facility. We're just pulling information from those systems out of there. So I wouldn't use that as a. Sorry, you were.
Well, that's what I would refer to as information management, not infrastructure management. Looking down the road in the future, what is your perspective on automating the facility, somewhat like IBM suggested that they might earlier today with an infrastructure management system that automates the HVAC?
So I would agree with that, but again, that's not DCIM. So DCIM to me is purely a management information system. It's not taking control of systems, because I'm again pushing this to thousands of users, and I don't want to push a platform to thousands of users that has the capability of changing the operational parameters at a facility. It's an information-based system, so it'll interact with those systems. It could push information back into those site-level systems, but I don't view that functionality as part of DCIM.
All right, great. And on vendor and platform independence, and how do you accomplish that?
So, as I mentioned at the site, and as you mentioned, we have, or I think the other questioner mentioned, we have lots of systems from all different manufacturers installed at our data center, in our data centers. So the key for me is to be able to use the appropriate protocols to reach into those systems and grab the data back. So once, at the shortest point. So if I'm installing, I'll install a server or servers at a facility with the sole purpose of doing the high-speed polling of all those points to get the information to a non-proprietary format, and package it, push those packets back to the non-proprietary DCIM platform that we have, which is an open data platform. So it's trying to convert from those proprietary protocols as close to the source as possible, get it onto a more IP neutral type communication protocol, and bring it back to the facility.
Hi. Question, yeah. So I'm assuming that you haven't built all of these pods, data centers, floors to some standardized specification. So you've purchased a lot of these potentially, and one of the challenges that I've run into is that in a legacy data center specifically, there's a lack of instrumentation in the infrastructure. So how do you deal with a lack of instrumentation in some of these sites where you have big gaps in data? Are you adding that instrumentation, or how are you dealing with the holes in the data as that rolls up?
Excuse me, that's a great question. So yes, we have a spec standard for the data we need. And so the first goal is to go to our facilities and get that from the systems that are installed. So if we have an acquired site that actually is not collecting that information, we're going to go back and add those points into a system. More likely, we will reach around the existing control systems and just grab that information correctly. So let me use an example. It's probably not an accurate example, but it illustrates what I'm talking about. So many facilities will take their UPS infrastructure and generator infrastructure and push alarms back to the BMS system, and then use the BMS system as a centralized alarming point rather than having multiple systems send alarms independently. So that's a pretty common model, and in that model we would connect up to the BMS system and get all that information. But if you weren't doing that, we wouldn't go back and say, let's connect the UPS to the BMS system, because that's a custom project. We'd reach right past that and connect directly to the UPS system and pull it in. So to answer your question, we have a specification of the information we need, and if the site is not configured with sufficient points to deliver that, we will add those points in so that we can have a consistent product across our portfolio. One more over here.
I have two questions. What portion of your total portfolio have you got this installed? And
So-
did you have a database expert company to partner with, or did you do it internally?
So, a couple of questions there. So, the entire platform, that centralized database, is installed, and we have it now installed at. If you see the press release, our press release basically said that we were rolling this out over the next 18 months. So, the central database, the platform, the program is installed and up, and we've now put it into a handful of facilities, and we're in kind of this last bit of testing before we start the rollout. So it's installed at a couple of sites. The software is already installed and operational, and we're just going around, we're beginning the rollout program. I'm sorry, what was the other question? Oh, so the question had to do with resources. So we have contracted with dedicated developers. So there's a development team that's dedicated to our, and working specifically for us. And there's a mix of in-house personnel and contracted developers who are working on the platform, specific for digital's use. And so, thanks so much. I think that's
There's one more question. Sorry.
I don't want to get in trouble. I'm
No, it's all good. In regards to who's going to be the user of Envision or the concept in general, who do you recommend be that individual? Is it the facility engineer? Is it the IT services data center manager? Or does a new skill set have to be developed in order to manage these incredible amounts of data?
It's actually all three of those. So our Envision platform integrates all of this information together. Facilities people are going to have a preferential view of what they want to see, and they can find that in the platform. The IT folks can have a preferential view of what they want to see. The beauty of that is that this filters out all of the stuff that, for an IT person, for example, it filters out all of the stuff that they don't really want to pay attention to. They don't want to see cycling pumps and things of that sort, stuff that facilities people need to see. They want to see the relationship of the power and the environment with their IT services. So it's really a broad base of people who are asking for this, and I don't expect that there's a new skill set. It's just empowering the existing people to look beyond their area of expertise and see a more integrated view of the entire data center operation.